All right, so for the first part, I've chosen to do number 3 from the first section of the worksheet. So let's go. All right, so the first thing we want to do is factor x squared minus 6x minus 16. So first, we have to think of a number that multiplies negative 16 and adds to negative 6, and that is 8, negative 8 and 2. So, and now these two binomials are going to kind of be our LCM. So what we're going to do is we're going to multiply the other side by x minus 8. Right, so now our denominators are the same, so now we have to multiply x plus 5 times x minus 8. So I'm going to do that right there. And this is just using the FOIL method. It's all right. And we combine like terms, and we end up with x squared minus 3x plus minus 40. All right, so our denominators are basically the same, so we can cancel those out for now. And all we need to do now is combine like terms, or here's a little thing I do to make it a little bit easier. So we just change the signs of the terms behind the minus sign, and we combine like terms, so we can cancel out both the x squareds, and we're left with 3x. 40 minus 3 is 37. And we can bring the denominator back, so we are left with 3x plus 37 over x minus 8 times x minus x plus 2. We're going to be doing problem B on section 2, so we have that all written out, and our main concern is getting the denominators the same. So we're going to be multiplying. So this term would be multiplied by x minus 4, and this one would also be multiplied by x minus 4, and this one is multiplied by x minus 3. All right, so now that we have that all taken care of, we can basically just cancel out the denominators and solve for the numerators. So getting that all situated. All right. So now we're going to start distributing. All right, so we've distributed, and we're going to start combining like terms. So that's going to turn out to be 2x squared, and that will be minus 2x, and that will be plus 4. And we have that negative 4x plus 16. All right, and we're going to take 16, subtract that from 4 on the other side, and we're left with 2x squared minus 2x minus 12 is equal to negative 4x. And we're going to go ahead and take 4 and add that to the negative 2, and we have this squared plus 2x minus 12. Right, because factoring the traditional way wouldn't get us the answers we want, we're going to use the quadratic formula. All right. So we're going to set this up for the first round, which is negative 2x plus the quadratic form of the trinomial, and all right. All right, so negative 2 plus the square root of 4 minus 4 times negative 24. So over 4, of course. All right, so we have negative 4 times negative 24, which is positive 96. And yeah, so we're going to write that out. And yeah, okay. So 4 plus 96 is 100. So we have that. And of course, the square root of 100 is 10. So we have negative 2 plus 10 over 4. And that rounds out to 8 over 4, which is 2. All right, so now we have the second one. So it's basically going to be the same problem up until basically the very last step. So we have negative 2 minus 10 over 4. And that's going to be negative 12 over 4. So in this case, x will equal negative 3. All right, now we have to check if the equation we were given is defined by either of these numbers. So first we're going to start out with 2. So we've plugged in 2 for every x place in the original equation. So we're going to go ahead and simplify that. All right. And we have that now. So negative 4 over 5 equals 1 over 5 plus 2 over negative 2, which is roughly 0.8 equals 0.2 plus negative 1, or minus 1. So, oh, excuse me, the 0.8 is a negative, of course. So we subtract 1 from 0.2, and we discover that, yes, x can equal 2. So we're going on to negative 3. So we've already replaced all the x values with negative 3, and we're going to be simplifying. Okay, so negative 4 over 0 is equal to negative 4 over 0 plus negative 3 over 1. And as you can see, negative 4 over 0 is equal to negative 4 over 0 plus negative 3 over 1 is not exactly equivalent. So 3 is not a solution, and x only equals 2. All right, so now we're moving on to question number 3 of the graphing portion. So what we're going to do first is we're going to graph our parent functions. So that's going to be at the points 1, 1, and negative 1, negative 1. All right, so now that we have those parent functions graphed, we can do the transformations. So x minus 6 implies a translation to the right 6 units. And the minus 2 also indicates a translation 2 units down. So those are our only transformations. All right. All right, so we're going to go ahead and plot those points. So we're counting over 2 units down. There's our first point. 1, 2, 3, 4, 5, 6. 1, 2. And there's our second point. All right. All right, so now we have to figure out our domain and range. So neither of the graphs seem to be able to cross at x equals 6 or y equals negative 2. So we have to note that. For the domain, x can equal all real numbers except for 6. And for the range, y can equal all real numbers except for negative 2. All right, so our vertical asymptote is equal to the value that is excluded from the domain. So that would be 6. And the horizontal asymptote is the value that is excluded from the range, which would be -2. All right, so our last step is to find the y-intercept. So what we're going to do is we're going to write out that equation, and we're going to completely exclude the x. So that gives us 1 over -6 minus 2, and we should get something like -2.166, and that's pretty close to where we are. So yeah.